Welcome everyone. So this is a lightning talk about containers live migration, what's there, what's missing, what's next. So containers live migration as a feature sort of lives in this quantum superposition state, and depending on who you ask, it's already there, it's already been done for 10 years or more. It's almost there or it's not there yet, not ready. So this is the most boring slide, so I'll just say that I'm Daniel. I'm based near Venice in Italy. I'm currently a cloud native engineer at ControlPlane. On the bottoms, there are some things I'm bad at, but I'm happy to talk about them. So what do we mean by live migration? We mean that is live, so we don't want the container, the processes in the container to stop. We want them to keep running and keep them running transparently. So it should be seamless. Think about like a context switch. What happens when the dispatcher takes the process from the ready queue? Think about it. So we want to migrate this process tree to a new host, a new execution environment. So we sort of have these three phases. The first one where we capture the state of the processes, of the workload. The next phase is where we actually move the workload to the new context execution environment, and then we restart the workload from the state that we just moved. This is in VMs, in virtual machines. It is more than 20 years old. If you think about VMware's vMotion was presented in 2003 for the first time. So it is sort of easier in the VM world because you have an hypervisor that has a complete view of what is running. Of course, the hardware is virtualized, so you can have also loose hardware compatibility between the two different hosts. All the hardware that effectively runs the workload is virtual. Of course, there are various optimization you can do when live migrating a VM. For example, you generally are required to use shared storage. Of course, you don't want to move everything over the network. But this is a talk about container live migration. So why is it interesting if in most of our use cases, containers are ephemeral? They are cattle, right? We are supposed to stop and restart them at will without caring so much. Well, is it really? There are containers that are more pet-like, like you might have stateful workloads, stateful containers. You might have containers that take a long time to start, and it is sort of undesirable to restart them often. You have containers that take a long time to execute, even if they are ephemeral, one-shot. For example, when you are executing an AI training, you don't want to lose all the progress or the resources. The minimum you want, at least in that case, it's a periodic checkpoint of the state of the container. Of course, if you would have effective live migration, you could also think about using spot instances. If it is able to complete in time, you just use spot instances for your nodes. You save a lot of money, and you almost don't feel any disadvantage compared to regular instances. And of course, if you're a sysadmin, think about zero downtime upgrades. You no longer need to work long hours or work in maintenance windows. There are also challenges, of course, in using containers. So, for example, we were talking about the state. What exactly is a process tree state? Who has the complete view? Is it the kernel? Is it the kernel and then someone else? Because we are using maybe external devices, GPUs, etc. There is the network, of course. There is no hypervisor in container. the containers might be running on different hosts with different operating systems, in the sense of course, still Linux. We are not talking about moving a container from Linux to Windows, but different versions of Linux. The promise of not breaking the user space is a strong one, and it's there. But if you're moving from a newer version of Linux to another one, not all features will be there, so you need to be mindful of that. And of course, there will be external resources, external hardware, disk mounts that might not be there in the next host. So it is difficult. Is it really possible? Guess what? This is a picture you might be familiar with. It is DockerCon 2015, and they showcased moving a container with an instance of Quake 3 Arena from one host to the other. There were some smoke and mirrors in that demo. For example, the file system was synced with SCP. There was no audio support, but it worked. So from this side, it's there. Container live migration, it has been for more than 10 years. So let's take a look at what's difficult about container live migration, that is capturing the state of the process, right? There are many projects that can do that. I will just mention two. This is a lightning talk, and I'm already going way too slow. So the first one was DMTCP, distributed multi-threaded checkpointing. It was starting in 2017, as you can probably guess from that SourceForge URL. It uses LD preload as a trick to inject its own hijack library and to then coordinate with the checkpoints event. It also had a 4.0 release this past June, so it is still actively maintained, but the thing is, if you want to migrate something with the DMTCP, you're supposed to start that command with the DMTCP launch, so it's not really handy. On the other side, we have Cryo, started in 2011, open source starting from 2011 from Virtuoso. Some mad Russians, as Torvalds called them when they submitted the first patches to the kernel. So Cryo is checkpoint and restoring user space. It is the de facto standard solution right now for container checkpointing and restoring. It is integrated in Linux Container, Docker, Podman, OpenVZ. Google's own Borg uses Cryo to live migrate its own tasks. It uses ptrace to attach to a process tree, and the coolest thing, it injects its own parasite code in the process space to coordinate with the checkpoint. It is in user space, so it collects all info from the proc file system, and it has tons of features and optimizations, like it supports incremental dumps, diskless migration, image streaming, etc., etc. So when you use Docker checkpoint, Podman checkpoint, you're using Cryo. If you want to live migrate a container, you're basically using Cryo and relying on Cryo. Most notably, also, Kubernetes checkpoint, it was introduced a few years ago with Kubernetes 1.25 in alpha and from 1.30 in beta. Initially, the use case is forensics. So there is only the checkpointing API available right now. You basically do a post request to the kubelet, and the kubelet saves a tar archive with the checkpoint of a running pod on the local node. So what's missing? The restore, of course. You just take the checkpoint. What do I do with that? That part is still very manual. There is no first-class support for proper live migration and end-to-end seamless process in the tooling. you can imagine that at some point, probably in the near future, we will have something like Podman move container to the next host. We will have a seamless live migration, so end-to-end process migration. This morning, there was a very interesting call about live migration in VMs in Kubernetes, and that, of course, requires CNI integration. So that is also something that hopefully in the near future will be there, and it is necessary for proper live migration. So what's next? Ideally, these slides will be the same as the previous one, but baby steps, right? So the next is encrypted checkpoints. And on Thursday, there's another talk at the Container Plumbing Days about enabling secure container checkpoint for distributed model training. So you see, the use case is always AI. Maybe that's where the money is, that's where the talk is, but it's also where it is actually very useful to live migrate a container by Radostin Stoyanov, so be there if you can. There are also planned improvement in the tooling, like in p-hole, in the image streamer, support for lazy migration, so having a pre-dump and then moving only the necessary memory pages, and proper checkpoint and restore API, maybe also not directly from upstream like the checkpointing API, but from out of tree related projects. There's, for example, this project a student started that uses an operator approach. So you create a pod migration object, and the operator manages taking the checkpoint, moving the images of the checkpoint to the other node, and then restoring. So yeah, things are bright. The technology is basically there. We just need to move all the pieces together to get a consistent experience. So these are just some of the references that I used for this talk. And I think I already talked too much, and before the red dot of a sniper kicks me out, thank you for being there. And if you have any questions, I will be happy to try and answer them.